Hi there, and thank you so much for joining me today. So in preparation for your first lab assignment, in which you are going to design an experiment, I have prepared this video to serve as an example for you as you're working on your lab assignment with your group members. So hopefully this will be helpful. Alrighty, so let's suppose that we are attempting to scientifically test the old adage, an apple away keeps the doctor away. Okay? I'm sure you guys have all heard that saying at some point in your life. So our research question for today is, does an apple a day keep the doctor away? Right? So right away, we can sort of start to map out what our experiment might look like, right? So just in a very general sense, the independent variable, or the variable that the researcher is going to manipulate, is apple, right? We can define that in any number of ways, but generally, we're going to manipulate apple consumption, presumably per day, right? So we have an apple group, we would call that the experimental group, and a no apple group, which we would refer to as the control group. Okay, so that's our independent variable and our levels of the independent variable. And then we have our dependent variable, which is the variable that we expect to change in response to the independent variable. Or another way of saying it, or another way of thinking about it is it's the outcome variable. Right? So our outcome variable in this case would be doctor. Right? So we can again operationalize that in a number of ways, but generally we're looking at how apple consumption impacts one's health, right? So let's go ahead and start with the first bullet point here. So it says define the independent variable and the dependent variable with operational definitions. All right, so let's start with our independent variable, which I've highlighted apple there for you. And before we start thinking about our operational definitions, let's go take kind of a general scope and instead think about what our conceptual definition is, right? So remember, a conceptual definition is basically just a theoretical definition that explains or describes whatever construct you're either manipulating or measuring. Right? So it's basically just a very general definition. Okay? So there are a couple different approaches we could have. So if you want to be very, very general, right, the conceptual definition of our independent variable is simply the presence or absence of an apple a day, right? So again, we would have one apple per day condition and a no apple per day condition. Okay, that's a very literal theoretical definition there. But we could also be much more abstract, right? So we could think of apple as being a symbol, if you will, for healthy eating habits, right? So simply having a diet that includes fruit and vegetables in it, for example. Okay, so those are two potential approaches, either a literal approach to the research question or maybe something more abstract. Okay, so next let's get to the nitty-gritty and talk about our operational definitions, right? So remember, our operational definitions are going to attempt to be as precise and detailed and specific as possible so that somebody else would be able to come in and conduct our experiment exactly as we conducted it for the purpose of replication. Okay, so our operational definition of apple Again, if we wanted to be as specific as possible, might be one small apple, which I asked Google how much small apples typically weigh, and I was informed that they were typically weigh 0.33 pounds, right? So again, if we want to be very precise and very controlled, we could weigh a bunch of apples and make sure they're all the same size, right? So one 0.33 pound Honeycrisp apple per day for 6 weeks, right? And again, that level of specificity is necessary because there's a lot. If you've ever been to Whole Foods or wherever, I'm sure you noticed that there are tons of different types of apples, right? In a very general level, there are red and yellow and green apples, right? But they also come in different sizes. They also are raised differently. Well, I guess not. Apples aren't raised, but um, they're created differently. So some apples are organic and some apples are not organic. You guys know what I'm saying, right? So there's a lot of variety when it comes to apples. So we need to be as precise as possible in selecting the type of apple that we're going to use in our experiment, right? And another really important component of an operational definition is going to be to specify lengths of time or units of measurement, right? So we know participants are going to eat one apple per day, right? But how long are we going to have our manipulation persist for, right? So just like we did with the breastfeeding intelligence example, we're going to specify a length of time. So they're going to eat one apple per day for 6 weeks. Okay? If we were to take the much more general approach and take apple as a symbol for healthy eating habits that include the appropriate number of fruits and vegetables per day, then our operational definition would be a little bit different. We would say that each participant in the apple condition or the experimental condition would eat 5 to 7 servings of fruits and vegetables per day for 6 weeks. Okay, so again, we have that level of specificity there. If we wanted to be even more specific, we could include a list of what acceptable fruits and vegetables are, if nothing else, to inform our participants. I personally know some people who think that popcorn is a vegetable, so we might want to give that specific information to both our participants and those attempting to replicate the study. Okay, so now we are ready to talk about our dependent variable, right? So again, we'll start with our general, theoretical, our conceptual definition, okay? And again, we could go two ways here. A literal approach would say, okay, how many doctor's appointments have you had, right? Presumably, if you go to the doctor, uh, that is an index of whether the apple is, uh, you know, um, serving its purpose according to this old adage, right? So we could say number of doctor's appointments, right, is our general theoretical definition. Or we could get a little bit more abstract and say, okay, number or keep the doctor away is a symbol or reference to one's general health, right? So do you have generally positive health outcomes when you consume either an apple a day or 5 to 7 fruits and vegetables per day? Okay. Okay, so now we are ready for our operational definition, right? So again, we want as much specificity as possible here. So it's a little bit easier with the literal definition if we're looking at number of doctor's appointments um, over the course of 6 weeks. One important specification, though, is we want to make sure it's number of doctor's appointments due to illness, right? So if it's just a doctor's appointment for a general checkup or maybe for a medication refill, we wouldn't consider that an index of general health. So it's a doctor's appointment due to illness, again, over the course of 6 weeks, okay? And with our more abstract conceptual definition, in order to have the specificity needed for an operational definition, right, we would specify the specific indices of health that we'll be monitoring. All right, so maybe we will look at cholesterol and blood pressure and maybe BMI as an index of the influence of apples or healthy eating on general health outcomes, right? And again, over the course of 6 weeks, right? And we could probably be even more specific here by adding, units or what have you. But just for the purposes of this example, we don't really need to worry about that. Okay, so now let's talk about potential confounding and extraneous variables that we might have to watch out for. So remember, an extraneous variable is something that changes the outcome variable or affects the dependent variable besides the independent variable. Okay, but critically, it's going to affect both groups equally. Okay, so it's not just going to affect the apple condition, it's also going to affect the no apple condition. And it's going to be the same effect for both groups. Right? So what's an example of that? Well, an example of that might be prior eating habits and health history of participants, right? That's going to potentially play a role in terms of affecting the general health outcomes, right? If some of our participants already adhere to a fairly healthy diet, right? So if they're already eating 5 to 7 vegetables per day and getting regular exercise and things like that, then we would expect them to have a fairly low cholesterol level and normal blood pressure, and their BMI would probably be within the normal range. As opposed to someone who ate very unhealthily, right? Then maybe the impact of now eating vegetables would be more pronounced for them, right? But again, we could say that depending on whether our participants were formally adhering to a healthier diet or not, is going to affect their general health outcomes, right? But those effects are going to be felt, right? Or those effects are going to be apparent in both the experimental condition and the control condition, or the apple condition and the no apple condition. But we also have confounding variables, right? So a confounding variable is also something in addition to the variable that we're manipulating that's going to exert some kind of influence on our outcome variable or the dependent variable. But in this case, it affects each group differently. Right? So we talked about two different types of confounding variables. The first was an individual difference confound, right? And this happens when something about our participants differs between the experimental and control conditions. So for whatever reason, we have a different sample, or a sample that differs in each of these groups, right? Or there's an observed difference between the sample chosen for the experimental group and the sample chosen for the control group, right? So I've given you an example here. If we had an apple group or experimental group that was entirely comprised of pre-med majors, right? It's certainly within reason to expect that someone with a more in-depth knowledge of health, right, might already be familiar with the deleterious consequences of an unhealthy diet, and therefore they might eat healthier than other majors, right? I'm not saying this is always the case, right? But it's reasonable to expect that if all of our experimental group was comprised of pre-med majors, we might see less of a difference in health outcomes, or we might experience better health outcomes, not just because of the apple, but because these people are generally more healthy anyway, right? And the same would be true if we recruited all of our participants for the apple condition at a yoga class, right? Or some kind of fitness class, and the same rule would apply, right? We would expect that a population comprised entirely of individuals taking a fitness class would probably be healthier in general than a sample comprised of people from the community or from a different population. Okay? So to solve this issue, we would again need to employ random assignment, right? So that we get some pre-med majors in both the apple group and the no apple group, and we get some, fit people in the apple group and the no apple group. Okay? All right. Okay, we can also talk about what are called procedural confounds, right? So again, procedural confound happens when the experience of your experimental group differs from the experience of your control group, or vice versa, right? Or said another way, the procedure that your experimental participants go through is different than the procedure that your control group participants go through, or vice versa. So again, I'll give you an example. What if, in addition to the apple a day, the apple group participants start a new fitness regimen, right? So they start kickboxing or something in addition to their daily apple, while your control group does not, or the no apple group does not, right? In that case, we don't know whether better health outcomes in the apple group are due to the apple or this new fitness regime, right? So critically, we need to hold all other factors, in this case amount of exercise, constant, so that there's only one thing that is changing between the experimental group and the control group. Okay, so the next bullet point, I asked you about participants. So who are your participants going to be, and where are you going to get them from, right? So maybe the simplest option would be to recruit directly from Mercer University, right? So obviously right now with COVID and everything, you guys know, there would be uh, a lot of other things going on potentially, so this wouldn't be maybe the best time to conduct this experiment. But for the purposes of this example, let's assume that there's no pandemic going on, right? So generally, for each level of the independent variable, you want at least 30 participants. So we have two groups. We have apple and no apple, or experimental and control. So in total, we would need 60 undergraduate participants. And when we're collecting our sample, we want to make sure that it's representative of the entire population of Mercer students, right? And we'll talk about this more when we get to sampling. But generally, we would want to make sure that we have some freshmen, sophomores, juniors, and seniors included. We would want to make sure that we have both males and females. And we would want to make sure that we include a variety of majors in both the experimental and the control group, because if we do observe a difference, right, we want to say that that difference is reflective of not just a small sample of students, but it's reflective of the general population. Materials, this is a fairly easy one for this example. So obviously if we're doing apples, we would want to have 6 weeks worth of, what would it be, 42 apples per person, or at least a scale to weigh each apple to make sure they're the same size. So we would need, 42 Honeycrisp 0.33 pound apples per participant. We would need some means of tracking our participants' appointments without, of course, violating HIPAA. So we would want a way to track that, maybe online or electronically. And then obviously we would need, if we weren't doing the literal definition, right, and we were instead looking at general health outcomes, we would want to have a laboratory in place that could conduct the blood test to see what those health outcomes are, and maybe a scale to weigh our participants to determine BMI, etc. All right, so generally our procedure. So what is our procedure going to be like for control and experimental participants, or apple and no apple participants? Okay, so well, first we're going to want to make sure that we randomly assign participants to either the apple or no apple condition. And then we're going to want to make sure that participants in both groups complete a general health screening to establish a baseline. Okay, participants in the apple group consume 0.33 pound Honeycrisp apples per day for 6 weeks. Participants in the no apple condition will not eat any apples for 6 weeks. So that's for the literal definition. If we were doing the abstract definition, it would be 5 to 7 fruits and vegetables per day or not. Okay. And then participants in both groups complete another general health screening to determine if anything has changed and if there is a significant difference between groups, right? So we would, if we were defining our dependent variable as general health outcomes, right, we would want to compare our baseline measurement to our end of 6 week final measurements, right? So generally, if we would see a reduction in bad cholesterol, or a decrease in BMI, or a more normal blood pressure after the 6 weeks, that would give us evidence that the apple manipulation was indeed causal in allowing for more positive health outcomes. If we were defining our dependent variable as the number of doctor's appointments, right, then we would compare the number of doctor's appointments due to illness between the apple group and the no apple group participants. And if we observed that there were significantly fewer doctor's appointments in the apple group as compared to the no apple group, that would generally support our hypothesis. Right. So predicted results in conclusion, like I said, participants in the apple group will show significantly decreased blood pressure, bad cholesterol, BMI, etc., compared to participants in the no apple group, or they will show fewer doctor's appointments. Um, and the general conclusion is that daily consumption of either apples or fruits and vegetables improves health outcomes. Okay? So hopefully this will serve as a example and jumping off point for you as you're completing your lab assignment in your groups. And certainly you guys can feel free to ask me questions if any part of this is unclear. Okay? All right, so I look forward to seeing all of you in my next video.